Welcome to part 2 of derivatives using data. Now, in this video, we're going to go ahead and just finish off the rest of the worksheet. So we have part F. Part F says for the model of the amount, a model for the amount of water in the tank is given by A of t, where A of t is measured in gallons and t is measured in hours. Find A prime of 15. This means the derivative at t equals 15. So this time we have a function, and the function is this A of t here. So we can find the derivative using the old method that we know. So it's going to be A prime of t is the limit as h approaches 0 of 1 over 225 minus t plus h cubed plus 30 t squared, well, not t squared, t plus h squared. $33,750 minus the original function. This looks like it's a lot of work, but I know you guys can do it. You guys are good. Okay. That is probably the biggest underline I ever had to draw. But there it is. There's your function. Well, there's your derivative function. It just needs to be cleaned up. Okay. So let me go ahead and clean this up. Okay, so I went ahead and just cleaned it up over here. I'm going to go ahead and explain what happened here. So notice that this 125 is a multiplier of this whole function here, and all I did was distribute the 125, the 1 over 125 into these four terms, but not after I've done the expansion of t plus h cubed and t plus h squared and also t plus h. Okay, now notice that the negative in front of the t plus h cubed also changes the sign. So whatever I cube, this blue part right here was simply this part here. Okay, and then the next part that I did was I took the times 30. Whoa, that's not gonna work. Okay, well, let me just do it in yellow. So I took the times 30 t plus h squared, I expanded that, and then because of the 225 in the bottom, it became as a denominator once I multiplied everything out. And then again, the 1800 t plus h, here it is, 1800 t and h with the 225 in the bottom. And then last is this guy right here, the constant that we distribute. And then the blue is simply just the original function. All of this, I just copied it over, except now I distribute the negative, which made the first term into a positive, and then the second term into a negative, and I still have some more over here, and there it is. It's very simple. All you got to do is just multiply everything out, and you have your answer so far. Okay, so now what do? We cross out like terms. I have a plus and a minus. What else do I have? I have a plus and a minus, plus and a minus, plus and a minus. So let me cancel these terms out so that way I don't get lost. All of these go away. Okay, so let's go ahead and just rewrite the whole thing. Okay, so I rewrote everything that survived, and I have a h in the bottom that needs to cancel. So I cancel it with this one. The square goes away, the cube becomes a square, that h goes away, that is just as h, and that h goes away. Oh, I messed up over here in the bottom. It's supposed to be 225. Okay. Alright, so let's see what's left. The limit as h approaches 0 of negative 3 over 225 t squared minus 3225 th minus 1 over 225 h squared plus 60 225 t plus 30 225h, and finally we have 1800 225 by itself. Now let's go ahead and apply the limit. Okay, so I'm going to apply the limit. H to 0 goes to this one, that one. So what does that mean? This term dies, this one also dies, and that one also dies. Okay, so let me go ahead and write it above here. So I'm going to write it on the top. What survives? Well, what survives is a prime of t is equal to negative 3 over 225 t squared plus 60 over 225 t, and then plus 1800 over 225. Now there's my derivative. This is my derivative. Now notice this is a cubic function, and the derivative of a cubic is a quadratic. So I have a quadratic equation now, so I know I did something right. Okay, so all we have to do now is plug in the 15. Don't forget about the a prime of 15 that we were originally going to do. So let me go ahead and get you guys that right now, and the answer is 9. Okay, so what does that mean? That means that if this water tank were to truly model this equation, that means that the instantaneous rate at which the water level was changing was 9 gallons per hour. That is the exact change of the water tank at 15 hours. Last one. Use the model given in part F to find the average rate of change. Well, so here we have, okay, so here's F, here's the model F. So all we have to do is find the average rate of change from 4 to 20 hours. So that means A of 20 minus A of 4 all over 20 minus 4. And let me go ahead and get you guys that in a bit. So there is my average rate of change, and all I have to do is just compute these. So I'm over here working with a calculator, so let me get you guys that in a bit. Of course, right now I'm using a cheap calculator, but if you have your own calculator, if you have the Inspires, make sure you store the values. All I did was just write the approximation. Okay, so what I'm doing is completely wrong. I'll have a slight error, and the change of the water flowing from 4 hours to 20 hours, it changed at an average of 5.928 gallons per hour.